Question number 4. Right. Projectile is fired at an angle to the horizontal. Okay, it's fired like this, which is initial velocity u. Vertical displacement, horizontal displacement is given. Okay, y versus x. Normal projectile motion. Here resistance is negligible. The path of the projectile is shown. Okay, good. Which gives the magnitude of the horizontal component. What happens to the horizontal component? If this is being fired at an angle theta, then the horizontal component is always the same, right? You know about this, which is nothing but u cos theta. Vx is equal to u cos theta. Now what is being asked is asking you which gives a magnitude. What do you mean by magnitude? Which means you have to ignore the sign over here. Okay, so anyway it is Vx equal to u cos theta, which is constant, which means this and this are incorrect, either of them are correct. Now, and the magnitude of the vertical component of velocity. Now see, between O and this point, the vertical component keeps on decreasing, and here what happens? It keeps on increasing. Here it is 0. What is being asked then? Okay, of the velocity of the projectile between O and P, which means what? This is your O and this is your P. So here what happens? Here what happens? Here the vertical component is 0. Here it is 0. Here little bit here. Then you see this increases. This becomes much more larger. This becomes much larger. And here it is very high. Which means what? The vertical component keeps on rising as it keeps on falling down. Which is the correct answer? So this is the correct answer. Okay. Let us move on to the next question.